Welcome to the Meteorite Apep Airsoft Landmine Assembly Guide. Now, I've got more or less all of the bits in front of me right now. I am missing the power switch because I could have sworn I had one laying around for this order, but turns out I'd used it up in something else. So I've got that coming tomorrow. Anyway, so we've got the printed parts here. We have the head. I haven't actually taken the support material off yet. So you print this up like that, and I use tree supports. Otherwise you end up with these bits here which you can't really use conventional supports for. So I've got to break off all the support material. And 20% infill, 4 walls, minimum 0.18 is what I think I did the final layer height at. And the customer wanted it in black. And this is the head, the chassis. You print that like that. Support again, conventional support though this time. 0.18 mil layer height again, 20% infill, and I think it's got about 4 or 5 walls to it, maybe 6 walls actually, and some ironing as well to smoothen out the fuse, and it just makes the print job a bit better. Next up we have the internal bits. We have, first of all, we have the striker, which is a elongated striker compared to the Meteorite family, and it needs to be slightly elongated because of how the chassis and head screw together. So we've got a slightly elongated striker. The fuse ring, 100% infill, 0.24 resolution, just needs to be solid. And then we've got the twist ring here, or the fuse ring, 0.12 layer high, 100% infill. I actually did this with 50% fan speed to make it a bit stronger, because this is what turns on the motor to fire the mechanism. And then the motor mount, that is 0.24 mil, print it up like that. With this, you print that up like that. And 0.24, 4 walls, 20% infill. This is just to hold the motor still. And there will be some slight play when the motor's inside. That's fine, doesn't matter. And then the slipper sear, which is a rounded sear here, 100% infill, 0.24 resolution at minimum. And when I say at minimum, what I mean is don't go any coarser than that, otherwise it might cause problems. Oh, we also have the base plate here, print it like that, 0.24 I think, or maybe 0.18, I can't remember. Probably did it to match. I can't tell, but yeah. All the print instructions are on the Colts page, and that's all the printed bits. For the electronics and the non-printed bits, you need a 5x50 bolt. I prefer these roofing bolts with the flat heads. That's for the fuse mechanism. Either a piece of AEG spring, ideally with the finished end, so to speak. Even if you have a whole AEG spring, you're only going to cut off a small section, but you want one with a smooth end. This is actually a 1.4 by 14 by 40 millimeter generic spring, and we're going to trim this to a certain length and then bend the spring with a blowtorch, like what you do with a Meteorite fuse system. You don't have to bend the spring on any of the systems. It's recommended just to make things a bit more stable and reliable, and on the Slam especially you don't really need to do it at all, but I'm going to be doing it because that is what I do for orders. And so yeah, you can use an AEG spring, or you can use a similar size spring if you can't find an AEG spring for some reason. Got some little screws here, can't remember the measurements, but they're used to hold the motor mount on and the base plate on. We have a 6 volt 100 RPM N20 gear motor with a D shaft. That is what fires it. Now we're using this rather than a servo because it is stronger, and also it doesn't require any extra voltage regulation circuitry. We do need, however, a small switching circuit, and you'll need a 2N2222 transistor or equivalent. This is an NPN transistor, and it's got a collector to emitter current, so basically the max current of around about 800 milliamps. I'm hoping this is all showing up, probably out of focus, knowing me. And this thing will not be drawing that much. I mean, these motors are rated for like 200 milliamps stall. But that gives you plenty of scope, and not only that, the motor's only going to be powered on briefly. So as long as you get a transistor with around about the same parameters, you should be fine. And we also have a 100 microfarad aluminium electrolytic capacitor. This just helps give a bit of smoothing to the power supply. You could probably get away without using this, but I always like to chuck one of these in a circuit with sensitive electronics just to make sure nothing gets upset. A resistor as well we will need, which is this value I think is 455 ohms. I haven't got the bag. 455 ohms. I say in the instructions use a 470 ohm resistor because that's a common value. I don't know what the colours are, but yeah, 470 ohms. This is slightly less, but it'll be fine. The reason why I'm using them is because I've got a bag full of thousands of them, so I'm just going to use them up. And then you need a HC SR04 ultrasonic sensor, or something equivalent, which has 4 pins: ground, echo, trig, and positive voltage. And this is what does the sensing. And also you will need a 1N4001 diode or some sort of rectifier diode. This is a flyback protection to stop the back EMF of the motor from damaging the rest of the circuit. I'm also going to chuck in a small fuse. The lowest one I could find is a 7.5 amp fuse in I've got a big pack of fuses. Ideally I'd go with something slightly less, but this will still give you plenty of protection. If something is going to fail, it will probably be the transistor anyway. If there's like if the motor stalls and the transistor gets stuck on, the transistor will probably burn out anyway. So, but the fuse will be there just to give you some extra protection from major short circuits. We've also got a battery connector, which in this case I like to use JST. So we've got that. It doesn't need to be that hefty of a battery. In fact, I've got the battery in my pocket. This is the battery I use for my one. It's just a little HBA 7.4 volt, 250 milliamp hour LiPo. So I've got that there for testing. And we got some grub screws as well. I can't remember the size, but to reinforce the ring. And then in here we have an Arduino Nano. I think it's a clone. Oh, it's a clone Arduino Nano. You won't need the header pins, so I will put them in a bag with a load of other header pins. But you just need the bare board, and you can then flash the code on it provided in the design. And this is what does all the controlling and it's the brains of it. And it also means that you don't have to do any really complicated wiring, because this all does all that. And any updates to the code I will release that allow you to then change how the mine performs, change the maximum range and all of that sort of stuff. Another thing as well I just remembered, we want to get some little 10mm silicone rubber soft closed door cupboard door things, and that will go into a hole on the top of the base to help lock it all together when it tightens up. And of course there's the power switch, which as I mentioned earlier I haven't got one, so that will be coming tomorrow, so I can then wire that in there and then. So first of all we're going to do the boring bit, which is to get all the support material out. There's also a few little bits of support material on the inside here. You can get rid of that if you want, it doesn't matter. I will do so it doesn't rattle around inside the mine if it comes loose. If you use a sharp knife as well, you can use that to get rid of any support material inside the sensor holes and the switch hole. The sensor holes will probably have to sand out anyway, so don't worry about scratching it up too much. And then I have a little technique to remove any of the stressed brightly coloured plastic, as well as removing any stringing, but we'll get onto that in a minute. Now I probably did this with a bit too high of a support interface density, and the interface is this hatching which allows you to break the support material off. It stops it bonding on as if it was a normal like print, you know what I mean. It can be a bit of a bugger to get off, so what I tend to do is I tend to get the large chunks of the support material off first, and then I will deal with the interface with a knife. It might take me about 10-15 minutes to clear it all off. Sometimes you get lucky and you rip a huge chunk of the interface off. So I'm going to grab my 11 knife, which is again very sharp, and I'm just going to use it just to gently scrape away the interface. Might take a while, but that's just the nature of the beast. And then the technique is you get a blowtorch. You want to be careful that of course you don't melt it, but you want to give it You see how it's going? Don't take the piss with it, because of course you will deform things, but if you just give it a quick lick with a blowtorch and let it cool, you can get rid of the stressed plastic colour. And it also will singe off any stringing, which is nice. And that looks a lot better now. Next up, we're going to introduce the head to the base, and this might take a bit of sort of bedding in because these parts have just been printed. But there we are. That's what it will look like broadly. It'll wear itself down with use, and to stop it from spinning around loose once it's all together, that is what these little silicone feet are for. We drop one in there, put some resin on top of it as well to hold it in, and that gives you a bit of resistance when you're pushing it back together, so that way it all aligns up. Next up, we're going to sort out the head of the slam. God, we're zoomed in, I just realised. And the tree supports are easy to snap, but getting the interface off as usual, bit of a fight. So what we're going to do is just gently use a blade. Right, so now we've got the support material off that, we will just make sure we get all the loose bits off, and then we'll get El Torcho. Turn it down a bit, that was a bit much. And there we are, much better. Of course, you're still going to get print artifacts. That is just, again, part and parcel. And we can now screw the two together, like so. And we have our M2 slam, and I can neaten up any of the print marks afterwards. There we go. Right, next up, we want to start sorting out the internal components. So we're going to move these over to one side where they won't get dirty. And the first component we want to sort out, or prepare I should say, is the ultrasonic sensor, the HCSR04. Now what I want to do with this is, if it was you doing it and you just wanted to do it quickly, you can just solder some wires onto the header pins and go from there. But I want to do a neat job of this, so I'm actually going to remove the header pin, or header pins I should say, and I'm going to directly solder some new wires onto the board. There we are. So now we've got the header pins off, we can take them out of the way, just plonk that in there for now. Now for the wiring, you don't have to use anything too thick, it's going to be pretty much all low current anyway. And what I'm going to use, I've got a box of wire here, bits of wire that I removed from some old print fans, and some spare wire here. Now we're going to use this for, well, obviously the positive and negative of the sensor, so we're going to chop that down. You don't have to do this, joining the wires directly on. Right, so I've just soldered the power leads on to the sensor, so we've got positive and ground, and you don't have to colour code it, I suppose. I often don't bother because I'm colourblind, so not really much point to me paying much attention to that, and I'm more than capable of just tracing some wires. This looks brown to me, but I think it's red. No, I think that's brown. So we're going to use that as the trigger signal. Right, so now we've got the wires soldered on to the sensor. Again, you don't have to do it straight off the board, but that's what I want to do. Not really paying much attention to the colours because I can't really tell the difference between them. Well, I can tell the difference between the red, white and black, but I don't know what that colour is. It looks brown to me, but it's alright, I'll be tracing the wires anyway. That's how I wire things up. So we just cut them a bit shorter. And what we can do now, just double check those joints, they seem to be alright. We can then insert this into the slam body, and what we're probably going to have to do first is just slightly enlarge the holes in the slam to allow the sensor to pass in. That's deliberate, so that it's a tight fit. Probably shouldn't have done that over the sensor, but there you go. So the sensor might still be a bit of a tight fit. You want the sensor to be a tight fit though, so it doesn't pop out on its own. And then what we're going to do is, if we use a driver to push on the back of the sensor through the slot, there we are. If you put a screwdriver through the reset slot, you can use that to help press onto the sensor to get that to seat into the body of the mine. I like to have them slightly recessed, try and make sure they're equal. That one needs to go a bit further forward. And we can also see the terminals and the wire colour from the back here as well. Oh, I forgot, there's a bit of support material that divides these two bulkheads. Pop that out. Now you want to put the sensor in before you assemble the fuse, which will be what we do next. Otherwise you will not be able to fit it round the fuse ring. So for the fuse, we want to take our twist ring and our motor, and you will need a source of heat for this. And what we're going to do is we're going to take a blade first of all, and we're going to slightly I'm not going to pronounce it because I can never pronounce it right, chamfer. So what we want to do now is we want to heat up the D shaft of the motor, and then we're going to align it with the D shaft on the ring, and then whilst it's hot we're going to push it into the plastic, and you want to make sure it is straight on the motor, or as straight as possible. It's not a really high precision thing, so if you do get it slightly on the wonk it's not going to hurt, but do try and get it broadly straight. We want to make sure there is very little resistance. So if there's any bits of plastic you need to shave off, you might need to use a knife to go around the edge of the yellow part just to take off any elephant fitting. But that feels alright, and of course we'll be putting a bit of silicone oil in there as well. And as you can see, that's moving okay. So that's alright. And we will be assembling the insides of the fuse in a second, but I want to get this bit done because this is the I wouldn't say fiddly bit, it's not that bad, but you know. So we'll move all the electric bits out of the way. Look at all this bloody support material everywhere. So now I'm going to grab the two little grub screws, and we need to screw them in to the size of the twist ring. So we have a hole there, that goes there, and a hole here. And what these grub screws will do, ideally we'd use some slightly longer ones, but these ones should be fine anyway, is, I keep losing them in the bloody support material. These will support the front and back of the shaft, so it will help take the stresses off the plastic. You'll have metal on metal contact rather than just plastic on metal, which would wear its way through the plastic eventually. When it comes to screwing these in, you want to screw them in slowly in and out so they cut their own threads. Otherwise you can end up with, if you're not careful, you can round the screw off. There we are, I can feel it bracing up against the shaft now. So that will help reinforce the interface between the motor and the twist ring. There we go. Now, incidentally, on the motor ratios, you don't really want to go any faster than a 6 volt 100 RPM one, because the faster you go, the lower the ratio you get. And also, if you go too slow of a ratio, too high of a ratio, you won't physically be able to move it back. You could actually damage the gearbox. So this one sits in there nicely, moves around nicely, and you can reset it nice and easily as well. Now with these motors, you have a positive mark on the back of the motor, and we want to wire this up in reverse. So we want to be putting negative into positive and positive into negative, because we need this twist ring, when it fires, to turn like that. It'll need to swing up to the side there. That's reset, that's fired. Now, we're gonna cut a spring down, and it's about 37, 38 mil. That's what I say now. It used to be about 35. What I do with these springs is I line up the cut bit on this end to the top end of it, and I just sort of do it by eye, and I think we end up with approximately, let's have a look. The calipers are buried in the bottom of that. This is not ideal, this. The numbers are worn off. It's probably about 38 mil long now. Because of how this fuse works, it's not as critical to get the bend absolutely. Mind you don't have to be that perfect with a bend when you're assembling them normally, but you want to get it broadly right. So we've got a 90-degree bend like that. We'll trim it down to a few mil, like so, and we will let that cool. And whilst that's cooling down, we will put the tap that I use. You don't have to use the tap. You can just force it through, the screw through, but it is a bit easier if you do it with a tap. So we want to get our sear, and we want to tap all the way through. And for the striker, we won't go all the way through. And so we have our striker that is tapped as well. Bolt's cooled, so what we can do is we can take our striker, align the arrow up with the bent end of the spring, and force it into the end of the spring. And there we are, we have our striker and spring assembly. You can use any bolt as long as the head's not too tall or too wide. I like these roofing bolts because they're low profile and easy to source. So we've got a bit of thread locker on the threads, and we'll tighten up the sear like so. And you don't have to be as critical about how tight the sear is on this one. So we've got the sear screwed onto the bolt. We will want to now test to make sure it fits. So we drop it down the fuse like that, and that feels alright. There's a bit of wear that needs to happen. The main aim is to make sure the sear goes up and down into the fuse cavity. And with this one as well, you can put some silicone oil in it. Do not put any grease in, or any oil or lubricant in the normal Meteorite fuses because of how they work. They are friction based. So now we can screw the spring and striker onto the bolt. So you want to put the cut end of the spring into the bottom of the fuse like that. It's a bit of a tighter fit because I haven't bent the spring as much as I normally would. Again, it's not necessary with these fuses. Now again, these fuses are a bit more tolerant because of what they are. And we're only going to put the screw partially through the striker. We don't want it going all the way through this time. So I've screwed the striker in, and as you can see, I haven't gone all the way flush with the bolt this time. That doesn't matter on these ones. You don't want it flush anyway. You want a bit of a gap, so that way the striker has a bit of extra reach. Right, next up we want to install the motor, the ring, and the motor mount. Now we want to line up the holes in the motor mount with the screw holes on the top of the fuse, very similar to a twist fuse. And we want to find the bag of black springs that has mysteriously disappeared. There we go. So as you can see, the twist ring now moves around, and if we put it up like that and push the mechanism in and twist that round, brilliant, it's now cocked. So what we're going to do to test fire it, bear in mind we've got to put a voltage into it in reverse. We have to power up the motor in reverse to get it to fire, unless for some reason this motor has been wound differently. Negative to the positive of the motor and positive to negative, and it should fire. There we are, that fired, and as you can see, the slam has fired. As we'll just solder on some wire onto the motor, and then we will move on to my favourite bit, because I'm a bit weird, which is the electronics. I'm going to put the red in the negative and the black in the positive on the motor. So again, I'm wiring it up in reverse, because if you try and power up the motor the wrong way, the fuse will not fire because it will try and turn the wrong way. Lead-free solder, of course, nothing wrong with it. I used to not like lead-free solder, but I think it's got a lot better over the years. About there, that's probably enough. I don't want to waste wire. I like to leave a bit in just to make things a bit easier in case any repairs or add-ons want to be added. So now we want to move over to, now that we've got all of these components inside the slam, apart from the power switch of course, as I've been over before, I'm going to screw this together and put it out of the way. So next up is the bit which a lot of you are probably going to find really boring, but I promise you it is worth it. We're going to be wiring up the Arduino. Now, I haven't put the code on the Arduino yet. I will do that once I've soldered it up. The pins that we need to pay attention to, we have, what do we have? We have V in and ground, that's where the battery voltage is going to go into. 5 volts, that's what's going to power the ultrasonic sensor. You cannot power the ultrasonic sensor straight off the battery, you can only run on 5 volts. We will need digital pin 2 for the transistor to fire the motor, digital pin 10 and pin 9 for the ultrasonic sensor. And so what we're going to do first of all, I think we are going to install the capacitor. So we're going to flip it over to this side, which doesn't have all the numbering on, and we're going to install the capacitor. So make sure you get the polarity right. The long leg is positive, and we want that to go to voltage in, and then the shorter leg needs to go to ground. There we are. We'll trim the ground lead down, and we'll do the same with voltage in. And so we've got our power smoothing capacitor on in the correct polarity. Next up, we want to install the transistor. Now, with the 2N2222, however many twos are, you have your emitter on the left, your base in the middle, and your collector on the right, if you're looking at the front of it, which is the flat part here. I will say at this point that you do have to have a basic level of understanding of electronics to build this thing. That is just the nature of the beast. But what we're going to do is we're going to splay the pins apart, and we're going to solder the, first of all we're going to trim down the base pin just ever so slightly, like that. It will become clear in a minute. And we're going to bend the pin so we can drop it into the ground via on this side of the Arduino, like so. We'll give it a bit of standoff actually so it doesn't touch those LEDs on the board. I'll just bend that down a bit, there we are. So now we've got the emitter soldered onto the ground via on that side. Next up, I'm going to tin the base of the transistor, which we trimmed down earlier. As you can tell, you don't need a board to do this. We're going to bend one leg of the resistor, and that's going to go into the digital pin 2 via. And then what we're going to do is we're going to just trim down the resistor, because we want the base of the transistor and the one leg of the resistor to overlap like that. In fact, what we're going to do is we're going to tin the other leg here quickly. There we are, and if we hold the other leg, which we haven't soldered yet, we can move it round. There we are. So I haven't soldered it onto the actual Arduino board yet, but we've got the middle pin of the transistor going to one side of the resistor. We'll flip it round and we'll solder the other leg. So now we've got the other leg of the resistor soldered in to digital pin 2. We're just going to trim those down a bit, and there we are, we have that. That's done. Next up, we're going to trim down the collector, which is the far right leg of the transistor. We're going to bend it out a bit and we're going to trim it down just like that, and we're then going to tin that. And then we are going to take our diode. Now, a diode has a grey band on it. That is our cathode. That is the direction that the electricity wants to flow. And what we want to do is we want the cathode, the banded end, to go to the voltage in pin from earlier on the Arduino, and the other side needs to go to the collector of the transistor. Now, what this does, you must make sure you get this on the right way, otherwise you will basically short the transistor out as soon as it's powered up, as soon as the transistor gets the signal to fire. Now what this does is it gets rid of any voltage spikes which you will inherently get from switching a motor. Whenever you're switching an inductive load, you will get a bit of basically a slightly higher voltage, or sometimes a significantly higher voltage, being spat back out by the motor. And if you don't protect the control circuits with flyback diodes, you can actually destroy the transistor. What I've done is I've soldered the banded end onto the voltage in pin, and if I show you what I've done now, we have the band of the diode going to the voltage in pin of the Arduino, and the unbanded end is going to the collector of the transistor. Make sure none of these connections touch any of the connections on the board underneath. So we have the emitter to ground, digital pin 2 to base via the resistor, and then the diode to voltage in. And what we'll do is we hook the motor between both sides of the diode, so that way we can power the motor and it gives you the flyback protection. If you get this the wrong way round, what will end up happening is the voltage will go straight from the battery, from voltage in, through the diode as soon as it connects. So make sure you get it the right way round, and if you omit this, you will probably end up destroying the transistor very quickly. So next up, we want to solder on the connections from the ultrasonic sensor. So these two red and black wires together. Now this pair of red and black wires is the positive and ground from the sensor, and that will need to go to a ground pin on the Arduino and the 5 volts. You cannot run these sensors off anything more than 5 volts, so we're going to use the onboard regulator of the Arduino to do that. So we strip the negative down, and we will have to piggyback off one of the connections already on the board, but that is no big deal. So we've stripped the negative, we'll tin it. So we've stripped the negative wire from the ultrasonic board, and we will tin it. And what we will do is we will trim that down slightly. We will solder that on to, we'll flip the board over and we'll go to the ground, which is connected to the emitter of the transistor. So we'll just put that in a clamp there and just double check. Yeah, okay, so that one there. So we're going to solder this to the ground on the back of the board here. So we're going to clean the iron tip a bit. So what we've done there is we've connected the negative from the sensor to the ground of the Arduino, and we're using the same connection, or the same via, which the emitter of the transistor is connected to. I'll tell you what, we'll just quickly neaten that joint a bit. There we are. And next up, we want to take the red wire, the positive from the sensor. We'll just double check. Yeah, positive. And that needs to go to the 5 volt pin of the Arduino, which is located there. Make sure we don't solder onto the adjacent pin, otherwise that will cause us problems. There we are, and we'll just use snips to make sure there's no bits of crap in the way. Make sure that you haven't got any little whiskers of metal on the circuit board. So now we have the positive and negative of the sensor connected to ground and the 5 volts. Next up, we're going to solder the trigger pin of the sensor to digital pin 9, which is up here at the top, conveniently next to digital pin 10, which is the one we will use for the echo. Again, we'll fold the wire over like so. Right, so we've soldered the trigger pin from the sensor to digital pin 9. The white one here, that's the echo, that's going to go to digital pin 10. And there we go, that is the sensor connected up. So to recap, ground to ground, VCC of the sensor to 5 volts, and then trigger to pin 9 and echo to pin 10. Now we're going to take the motor wire, bearing in mind that whilst the motor is wired in reverse polarity, we still want to connect red to positive and black to negative because we've already reverse connected it, you know what I mean. We want to connect positive to V in, so this side of the diode, and the negative to the other side of the diode. And there we go, that's our motor connections, and we will be connecting the battery, the power into the Arduino onto voltage in and onto a ground pin, so we'll probably go off the one adjacent to it, or we might go off to that one there. So that way we have the power going into the Arduino. So that is all of the components wired up. What we will do next is, I suppose, we'll go put some code on this thing. Now excuse the messy bench, but we have the code here. And we have it on the Arduino software, and this does not want to focus. There we are, Arduino on COM12. We haven't actually put the code onto it yet, so we will do so. So upload. And that beeps good. I know it's a bit noisy in here, so you probably can't hear the beep. But that is part of the code. So that is the code working on this. The motor's beeping as it should, the sensor's detecting as it should. So next up, I suppose, is the bloody power switch. Right, switches have turned up, so of course the packaging is going to be a twat and not come apart properly. Right, switches have arrived. For some reason these come with red and black, so what we're going to do is we're going to remove the black one, cut the heat shrink off, and then desolder it, save the wire for something else. And then we're going to use this wire, put a fuse in line, and then that will go to the positive connection inside the SLAM. Right, so we've got the switch wired in series with voltage in and the positive side of the JST connector. And then what I'm going to do is I'm also going to put a fuse in line the positive feed, just in case, just to make sure nothing goes bang. So what we're going to do now is we're going to change the fuse that I just blew because I accidentally connected the negative to the positive on the Arduino board, and the positive was also connected to the positive, so we got a dead short. But it's good to know that the fuse will at least blow. I mean, it doesn't mean I've got to grab another damn fuse and desolder all this lot, but there we go. So positive to V in, ground to ground. Right, okay, there we are. Let's try again without blowing up the fuse this time. At least it wasn't anything major that blew up. There we are. Right, that works. So we'll do a functionality test. We'll cock the SLAM, turn it on, and we'll let it arm. Oh, for Christ's sake. Right, so now, bang, okay. That's the tripwire mode. Let's do the dead man, not the dead man's hand, the booby trap mode. Once this is done, we will then be soldering, no, we won't be soldering, we will be cable tying up the insides, neatening it all up. And then, I tell you what, whilst we're waiting for that to arm, we'll put the magnets on. Now be careful with these magnets because they can be a bit brittle. Ah, it's just finished arming. So we lift that off, bang. Okay, that's all the electronics working. We're going to quickly put the magnets on the back here. So we've got a screwdriver. Don't over tighten these screws holding the magnets on because you can actually crack the magnets. Right, that's all of the magnets done with a bit of play, so they shouldn't split or crack. Also means they will sort of stick and sort of contour around whatever you're sticking it to. I'll put that out of the way, and we will start trimming things down, and that will tuck into there nicely. And we want the Arduino to sit on top, so that way it stays out the path of the motor. Doesn't need anchoring down, it will all be held in place just by the wire. I mean, that's not going to shake around. We'll tuck that in there, and we've got the base plate here. We've got to break some of the support material off on the ends. So that is the base cover on. Next up, we just want to make sure there's no stuff in there. We will take one of the silicone things. I'm actually going to go get some glue to stick this in, because sometimes they like to not adhere properly, so I like to give it a bit of helping hand. And we'll get a bit of this UHU and we'll run some around the edge of this thing, sort of to pot it into place. And we've got the battery thing there, that can be tucked in there. And then we will plug in this for a final check, make sure nothing's been fundled with or squished. So push down, wind that, yeah, that's nice and smooth. And then we'll turn it on and let it arm. And now that's armed in trap mode, bang. And what we'll do now, we'll tuck that in there and we will screw the lid on. You might have to press the little bumper down like that, and if we'll keep it upright, that means the glue will sit down, then it will hold it in place as it dries. And that is a fully assembled Meteorite Apep M2 Slam. I think I've remembered everything. So anyway, yeah, I hope that helps. Thank you very much for all the support and all of the business. If you have any questions about how you assemble your Meteorite Apep, then please make sure you leave them down below. And thank you very much for watching.